Yes, sir. I am here. ಬಂದ್ರ ಸರ್ ಅಲ್ಲೇ ಲ್ಯಾಪ್ಟಾಪ್ ಅಲ್ಲಿ ಡಾಕ್ಟರ್ ರಘುವೀರ್ ಬಂದಿದ್ದಾರೆ ಸರ್ ಇಲ್ಲಿಂದಲೇ ಹೋಗಿ ಸರ್ ಈ ಡೋರಿಂದಲೇ ಅವ್ರು ರಘುವೀರ್ ಆನ್ಲೈನ್ ಅಲ್ಲಿ ಇದ್ದಾರೆ. ಹಲೋ ಸರ್.
Hello.
Sir, shall we begin in another
Yes.
3 minutes?
3 minutes. Okay.
Yeah, it's about to getting 30.
Okay. It will go up to 4:30, no? 3:30 to 4:30.
Yes, sir.
Yes.
There may not be questions because you know the students, they won't ask questions. We have to ask.
Anybody is questioning? No.
No.
Nobody responds.
Yeah, there is one more webinar going on. I am doing side by side. Yours and others. That is biotechnology for PUC and science degree lecturers statewide.
Okay.
That is also we are only hosting. So I am both this and that side.
I am not able to hear you properly. What is the problem?
Because the room is echo. That is the reason.
Okay.
We are not soundproofed. We are just yet to commission the office.
Okay.
Newly built building.
Yes.
Yeah.
I am audible, no? No
Yes,
problem.
sir. You are clear.
Yeah.
So shall we start, sir?
Yes. Tell me.
Yes, I'll give you 1-2 lines of introduction, then we can go.
Yeah.
Sir? Yeah. ಎಲ್ಲರಿಗೂ ನಮಸ್ತೆ. ಕರ್ನಾಟಕ ವಿಜ್ಞಾನ ಮತ್ತು ತಂತ್ರಜ್ಞಾನ ಅಕಾಡೆಮಿ ವತಿಯಿಂದ ನಡೆಸ್ತಿರುವ ಟ್ಯಾಲೆಂಟ್ ಸರ್ಚ್ ವೆಬಿನಾರ್ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಸ್ವಾಗತ. ಇವತ್ತಿನ ಅಟಾಮಿಕ್ ಸ್ಟ್ರಕ್ಚರ್ ಎನ್ನುವ ಟಾಪಿಕ್ ಅನ್ನ ಡಾಕ್ಟರ್ ರಿಚರ್ಡ್ ಗೊನ್ಸಾಲಿಸ್ ಅಂತ ಅಲೋಸಿಯಸ್ ಕಾಲೇಜ್ ಮಂಗಳೂರು ನಿರ್ದೇಶಕರು, ಲೋಯಲಾ ಬಿಲ್ಡಿಂಗ್, ಇದರ ಸೈನ್ಸ್ ಸ್ಟ್ರೀಮ್ ನ ಡೈರೆಕ್ಟರ್ ಅವರು. ಅಲ್ಲದೆ ಇವರ ಕರಿಯರ್ ಬಂದ್ಬಿಟ್ಟು ಈಗಾಗಲೇ ಹಲವಾರು PhD ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ಇವರು ಗೈಡ್ ಮಾಡಿದ್ದಾರೆ. ಮಂಗಳೂರು ವಿಶ್ವವಿದ್ಯಾಲಯ ಮತ್ತು ತುಮಕೂರು ವಿಶ್ವವಿದ್ಯಾಲಯದಲ್ಲೂ ಇವರು ಪ್ರಸ್ತುತ PhD ಸ್ಕಾಲರ್ಗಳಿಗೆ ಗೈಡ್ಶಿಪ್ ತಗೋತಾ ಇದ್ದಾರೆ. ಅಲ್ಲದೆ ಹಲವಾರು ರಿಸರ್ಚ್ ಲೇಖನಗಳನ್ನು ಇವರು ಪ್ರಕಟಿಸಿದ್ದಾರೆ. ಅದು ಅಲ್ಲದೆ ಸಂತ ಅಲೋಸಿಯಸ್ ಕಾಲೇಜಿನ ವಿವಿಧ ಇಲಾಖೆಗಳಲ್ಲಿ ಅಂದರೆ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ಗಳಲ್ಲಿ ವಿವಿಧ ಹುದ್ದೆಗಳನ್ನು ಅಲಂಕರಿಸಿ ಪ್ರಸ್ತುತ ನಿರ್ದೇಶಕರ ಹುದ್ದೆಯಲ್ಲಿ ತಮ್ಮ ಕಾರ್ಯವನ್ನು ನಿರ್ವಹಿಸ್ತಿದ್ದಾರೆ. ಸೊ ಓವರ್ ಟು ಯು, ಡಾಕ್ಟರ್ ರಿಚರ್ಡ್ ಗೊಂಸಾಲಿಸ್ ಸರ್. I welcome you on behalf of KSTA and all the participants who are here. Thank you, sir.
Thank you, Anthony, for your introduction. Let me start. Atomic structure topic I am starting with. This is the topic of the first PUC. ಪರಮಾಣುವಿನ ರಚನೆಯ ಕುರಿತು ಒಂದು ಫಸ್ಟ್ PUC ಟಾಪಿಕ್ ಅನ್ನು ತಗೊಳ್ತಾ ಇದ್ದೇನೆ ಇವತ್ತಿಗೆ. We will discuss. We start with Dalton's atomic theory. This is the introduction. In 1808, Dalton gave a theory about the atoms, and this is how the theory goes. The elements are made up of small indivisible particles called atoms. Atoms can neither be created nor be destroyed. They can take part in the chemical reaction, and number of atoms must be present before and after must be the same. In a chemical reaction, atoms will remain the same. Atom is the smallest particle of an element which take part in a chemical reaction. Atoms of the same element are identical in all respects, size, shape, and mass. Atoms of different elements have different mass, shape, and size. This is an idea. Therefore, what was told is matter is made up of smallest particle which are indivisible, which are nothing but atoms. That is what the theory, Dalton theory says. Discovery of subatomic particles. Everybody knows now that atom has three fundamental particles: proton, neutron, and electron. When this was discovered, we shall see now, cathode ray consists of negatively charged. You can see a figure of a cathode ray. A discharge lamp or a discharge tube is there, and there are two electrodes, one cathode, another one is anode. You are using a very high voltage of 10,000 across the two electrodes, and pressure is kept very low pressure gas is kept inside. What happens is, when this electrode is heated, electrons are emitted. A flow of electrons take place from the cathode to the anode. Therefore, they are called cathode rays. Flow of electrons are called cathode rays. That is how the cathodes were discovered. Cathode rays themselves are not visible, but they cause fluorescence on the material. Therefore, if you have a material on the walls of the glass, zinc sulfide, that will be illuminated. As a result, you will be able to see the effect of it. Otherwise, they are invisible particles. You can see the illumination on the zinc sulfide screen. In the presence of electric and magnetic field, cathode rays get deflected. If you apply an electric field perpendicular like this, they will either move towards or away from this. That is how you can do it. Cathode rays produce heating effect. When those element rays are made to strike on a metal foil, the foil gets heated. Therefore, what we understand here is, by this experiment, electrons were discovered. J.J. Thomson discovered electron. Electron was discovered by J.J. Thomson. The value of charge is 1.6 into 10 to the power minus 19 coulombs. Negative charge is the charge of an electron. Mass of an electron was also established as 9.1 into 10 to the power minus 27 grams. If you calculate E by M experiment, you can calculate the mass of an electron, 9.10 into 10 to the power minus 27 grams. Or if you kg, if you write 9.1 into 10 to the power minus 31 kg. Please remember, this is the mass of an electron. Discovered by J.J. Thomson in 1897. Proton was discovered by Rutherford in 1919, and proton is positively charged, having the same charge, and mass is almost similar to neutron. Neutron and proton have almost similar mass. Coming to discovery of neutrons, it was done by James Chadwick in the year 1932 by bombarding beryllium-9 with alpha particles. They got neutron. Interestingly, neutron is not having any charge, but having mass 1. 1 is very similar to the mass of the proton. Slightly heavier than the proton, but mass is almost similar to that of the proton. By the discovery of these three fundamental particles, J.J. Thomson predicted, because at the time of J.J. Thomson, only electron was discovered. And people knew that Dalton said that atom is neutral. Therefore, he said, if electrons are present, and the positively charged particles are also present so that the entire atom is neutral. This is the model that was given by J.J. Thomson. J.J. Thomson gave this model where the positively charged particles are distributed equally, where the negative electrons also spread equally like this. This is called plum pudding model that was given by J.J. Thomson. Then there was a famous experiment in 1911, I think. Rutherford allowed a narrow beam of alpha particles. Here, this is a source of alpha particles. It is made to pass on a thin gold foil and studied the subsequent path of these particles with the help of zinc sulfide coated on a screen. A circular screen you can see there. On this zinc sulfide screen, what we find that most of the alpha particles just pass through and you could see the illumination everywhere. And the particles are dye-positive helium ions. You should know that helium ions are alpha particles without electron. Helium has 2 units of mass, charge, and 4 units of mass. 2 units of positive charge and 4 units of mass, having mass 4 units and charge 2 units. And they are going through the gold foil. You can see when they move through the gold foil, what happened? Most of the alpha particles were unaffected. They just moved like this. I will show you. If I can show you here, this is the gold foil, let us say. 90% of the particles just moved here and they cause the illumination here. Very few particles get deflected. Very few particles get deflected. And 1 in 20,000 retrace the path. 1 in 20,000 retrace the path. From this experiment, what they came to know is most of the atom is empty. Gold leaf contains the gold atoms. Gold atom, most of the atom is empty. Therefore, most part of the atom is empty. The fact that few particles are deflected indicates that some part of this atom is having the nucleus heavy, the other part is empty part. Therefore, nucleus, the mass of an atom is concentrated, mass and charge of an atom is concentrated in a small area called nucleus. That is what the conclusion is. The fact that 1 in 20,000 get deflected indicates that the volume occupied by the charge body is very small compared to the total atom. Therefore, so far, this is the model given by J.J. Thomson this time. Now, because of this new experiment, alpha ray scattering experiment, what we are saying is the mass of an atom is concentrated in a small area called nucleus here, and electrons are found outside. Electrons are found outside. This is the model is now coming out because of Rutherford. We shall see that. Rutherford atomic model. All positive charge and the mass of the atom is found in a very small region called nucleus. The size of the nucleus is very small. See the diameter of the nucleus, 10 to the power minus 13 centimeter or 10 to the power minus 15 meters. Whereas diameter of the atom is 10 to the power minus 8 centimeter or 10 to the power minus 10 meters. Diameter of an atom is 10 to the power minus 10. Of the nucleus, 10 to the power minus 15. Very, very small nucleus. Most of the space outside the nucleus is empty. Electrons equal number to the net nuclear charge revolve around the nucleus. The centrifugal force arising due to revolution of an electron balances the force of attraction of the nucleus and the electron. Therefore, when the electron is moving in circular orbit, there is a centrifugal force which is balanced by the net force of attraction between the nucleus and the electron. Therefore, this is very important. This is an idea which is given by Rutherford model. Now, the exact position. What is the defect of Rutherford model? Defect of Rutherford model, you can see the exact position of electron from the nucleus are not mentioned. Exact position of electron from the nucleus are not mentioned. You cannot detect the exact position of an electron in an atom. And what happens is, more importantly, the stability of atom is under question. If an electron is moving, let us say here, this is the nucleus, electron is moving here, a moving electron should lose energy according to Maxwell's theory. If it is moving electron loses energy, it is getting attracted by the nucleus. It will come closer and closer and ultimately fall into the nucleus. Therefore, into the nucleus in 10 to the power minus 8 seconds, very small time. Therefore, atom should be unstable. Atom is unstable. This is the problem of Rutherford model. Now we go ahead. Some terms that are used in atomic terms, atomic number, there is a term that is used. What is atomic number? Atomic number is number of protons or number of electrons. That is called atomic number. Now, if I write an atom, let us say here I will write on the top. This is an atom X. This is A, this is B. If I write, this is number of protons or number of electrons. That is called atomic number. That is. Nucleon is here, B. Nucleon is number of protons plus number of neutrons. Put together is nucleon. Both nucleons are number of protons and neutrons present inside the nucleus. Mass number is almost same. The number of nucleons is the mass number. Mass number is B here, A is the atomic number. What are isotopes? Isotopes are atoms of the same element having same atomic number. Same element means same atomic number, but mass is different. Then they are called isotopes. For example, hydrogen has 3 isotopes. This is called protium, this is called deuterium, this is called tritium. What are isobars? Isobars are the atoms of different elements having same mass number, but atomic number is different. One is 15, another one is 16. Then they are called isobars. What are isotones? Atoms having same number of neutrons. What is neutron? Neutron is mass minus atomic number is neutron. 14 minus 6 is 8. Check. 16 minus 8 is also 8. This is the number of neutrons. If the number of neutrons are same, then they are called isotone. What is isoelectron? Isoelectronics are those having same number of electrons are called isoelectrons. For example, O2 minus. O has 8 electrons. 2 minus means 8 plus 2. Minus means you should add the electron. 10 electron it has. Neon has 10 electrons. Sodium. Sodium has 11 electrons. Atomic number is 11. Because you write plus, you minus 1. Therefore, number of electrons are 10. Magnesium is 12. 12 minus 2, 10. Therefore, all of them have 10 electrons. Isoelectrons. Isosteres. Molecules having same number of atoms and also have the same number of electrons are called isosteres. Nitrogen. How many atoms are present? 2. Number of electrons are 7 plus 7, 14. Number of atoms are 2. But number of electrons are 6 plus 8. Oxygen is 8, carbon is 6, 14. Carbon dioxide and N2O, same. HCl and F2, you can check here. Number of atoms are 2. H is 1. Chlorine is 17. Together is 18. Fluorine is 9 plus 9, 18. These are called isosteres. Isosteres should have same number of atoms and same number of electrons. Isodiapers. Atoms having same difference between number of neutrons and number of protons are called isodiapers. What is it? They have the same A minus 2Z value. Same number of neutrons and same number of protons are called isodiapers. For example, their values should be this. Difference should be this. Mass number minus 2 into number of protons will give you this This number, if it matches, then it is called isodiapers. For example, you take uranium-238. What you do is 238 minus 2 into 92. You do it. You will get the answer. But you go for thorium-234. There also you do it. 234 minus 2 into 90. The answer should be same. Check here. 186 here. No, 184 here. 184. Therefore, if you subtract 184 from 238, this comes to 4, 3, 8, 15, 8, 5, 13, 54 is the difference. 54, 154, no, 54 is the difference. Here. Here also it will be the same. 180, this is also 54. If the number match, then it works. You do it here. This is much easier. This and this. Does it match here? Here, A is 3 minus 2, that is 2 into 1. That is equal to 1. Here you do it, 7 minus 2 into 3. This is also 1. Therefore, these are called isodiapers. Isodiapers should have same isotopic number. How do you find isotopic number? This is the formula. A minus 2Z is the formula to find out isotopic number. Then they are called isodiapers. Next, electromagnetic waves. Now we are moving from wave, we are trying to find out from the particle, we are moving towards the wave. Therefore, electromagnetic wave, when we speak, we should have some details about this. Wave means what is wavelength. I will show you what is wavelength. If I write a wave like this is a wave. This to this distance is called wavelength. Distance is called wavelength. Distance between two consecutive drops and or two consecutive crests is known as wavelength. I can say what is this? We will go here. Put this way. Between this point and this point, this is crests, two crests. Or if you go by this point and this point, that is called wavelength. Wavelength, distance between. It is denoted by lambda and it is given in nanometer, angstrom. See that angstrom is 10 to the power minus 10. Micron is 10 to the power minus 6. Picometer is 10 to the power minus 12. Frequency. What is frequency? Number of waves passing through a given point per second. How many crests are passing through this point per second? That is called frequency, given in hertz or per second. Velocity. Distance traveled by a wave in 1 second is called velocity. For generally, velocity of light is 3 into 10 to the power 8 meters per second. This is the velocity of light. Velocity of sound is different. Velocity of light is different. Therefore, electromagnetic waves, when I say light waves are having velocity 3 into 10 to the power 8 meters per second. What is the relationship between the frequency, wavelength, etc., wave and wavelength? You see, you should remember this formula. C is equal to nu lambda. C is the velocity of light, nu is the frequency, lambda is the wavelength. Therefore, I can easily calculate lambda. Lambda is equal to C by nu. Is given here. Remember this formula from which we can derive other relationship like this. Wave number. It is defined as number of wavelengths per unit length. In one length, 1 meter or 1 centimeter, how many waves are there? That is called wave number. Therefore, wave number is given by the formula 1 by lambda. Lambda is C by nu, therefore it will become nu by C, reverse. 1 by lambda is nu by. Amplitude. It is the height of the wave. Height of the wave is given by amplitude. Time period is a reciprocal of frequency. Reciprocal of frequency, 1 by nu is called time period. Need not give importance to this one point here. Time period is not required This part you need not study. The other things, first few points you keep it in mind. Electromagnetic spectrum, please notice. Various radiations, electromagnetic radiation, are arranged in one order. What is this order? In the increasing order wavelength, you can see. The shortest wavelength is here. This is wavelength, check. 10 to the power minus 16. And the longest wavelength comes here, radio waves, that side. This arrangement from this side to that side is called electromagnetic spectrum. Gamma rays having the highest energy, shortest wavelength, then X-ray, UV, visible, infrared, microwave, then all radio waves. Radio waves, FM, AM, all those things come there. This arrangement is called electromagnetic spectrum. What you should know, gamma radiations are having highest energy, and radio waves are having lowest energy. This part you should know. Then comes a very important postulates of Planck quantum theory. Max Planck gave an idea saying that energy is not continuous as Maxwell says. Electromagnetic waves radiate energy in packets, bundles, packets called quantum. Quanta is plural, quantum is singular, smallest packet. And energy associated with a packet is given by E is equal to h nu, where h is called Planck constant, nu is the frequency. The value of h is given here. And body can radiate, absorb, or propagate energy in multiple subquantum. H nu, 2h nu, 3h nu, no fraction in multiple, integral multiple subquantum is what we can say. Yes. Then we move to Bohr's model. Bohr gave a theoretical model for the atom, and for which he got the Nobel Prize also, Niels Bohr. What he said? He said one thing, a modification of Rutherford model. He said nucleus is here. Electrons can move in fixed orbits around the nucleus. Fixed orbits. They cannot move in between. Either they should move in this or here, fixed orbit. Therefore, electrons revolve around the nucleus in circular orbits without losing energy. As long as it is moving in these fixed orbits, they don't lose energy. Yes. And only those orbits are allowed where angular momentum of an electron is an integral multiple of h by 2 pi, where n can be 1, 2, 3. This is only those orbits are allowed. Okay. These orbits are called stationary states, all. But only when an electron from higher energy level, E2, jumps to E1, then only it will radiate energy. When it jumps from E1 to E2, it absorbs energy. E2 to E1, it will radiate energy. E2 to E1, if it jumps, it will get H. This is what Bohr's model says. Therefore, Bohr's model says when you fix the electron here, move here, it does not lose energy. That gives stability to the atom. Second one, only when it jumps from here to here or here to here, then only there is a change in energy. This is what is said by Bohr's model. He gives a lot of things. What you have to by heart would be this formula you remember. I am not touching upon those things. I will make it simple. Radius of any orbit, remember, 0.529 is the radius of the first orbit of Bohr's orbit for hydrogen, 0.529. Remember as 5.3. If you feel that 529 is 3 digit, make it 5.3, 0.5. N is the shell to which electron belongs, n squared by z. That is the atomic number. For hydrogen, atomic number is 1. Therefore, for this first orbit, what is the radius of the first orbit of hydrogen? 0.53 angstrom. Why it is so? N is 1. What is the radius of the second orbit? If I ask you for hydrogen, N is 2. 2 squared is 4. Multiply by 4. 4, 3 is the 12. 4, 5 is the 20, 21. 2.12 angstrom. Like that you can find out. But that is important provided you are not asked for hydrogen. If you are asked for, let us say, helium, that becomes 2. Beryllium, 3. Then comes other elements. Lithium is 3. Beryllium is 4. Boron is 5. Carbon is 6. Like that for other elements, that you should remember. Therefore, just remember this, other things need not worry. Here also, I will make it simple. Remember this. Sorry, not this. Erg is not required. You remember only this. Energy per atom. Remember. Minus 2.18 into 10 to the power minus 18 joule per atom. This you remember. Per atom. Now, if they want per mole, this is 1312 per mole. That means multiply by Avogadro number 6.022 into 10 to the power 23. These many atoms are present in a mole, then it will become minus 1312. That's squared by n squared kg per mole. That is the Z atomic number. N is the number of this. For hydrogen, Z is 1. Therefore, automatically it will become 1. This is 1. Don't worry about these two. This value you remember. If you give in terms of electron volt, remember minus 13.6, that's squared by n squared electron. That also you remember. Electron volt, this and this. 3 values enough. That's squared by n squared. To work out problems, I am saying. And then remember this. Velocity of an electron, remember this. 2.18 into 10 to the power 6. 10 to the power 6 enough. 6 centimeter will change to meter automatically. That by n. That by n meters per second. This is the velocity per electron. Remember. Other things not required. Merits of Bohr's theory. The experimental value of radii, you can calculate energy, radius, velocity, etc. We can find out. Explain them. It explained the emission spectra of hydrogen. Experimental values of spectral lines have close validity with the calculated values of Bohr's theory. This is one. Limitations of Bohr's theory. So please remember, does not explain spectra of atoms having more than 1 electron. Complicated electrons are there. Let us say helium has 2 electrons, lithium has 3 electrons, beryllium has 4 electrons, then it will become more complicated. Bohr's theory cannot explain. Second one is each lines what you get in the spectrum will be split into number of lines, both in electric field and magnetic field. Magnetic field is called Zeeman effect. Electric field it is called Stark effect, which cannot be explained. Third one is de Broglie said that electrons will have dual nature, both particle nature and wave nature. Bohr treated that electron is only a particle, not a wave. Another objection for Bohr's theory is Heisenberg's uncertainty principle, which cannot be explained by that. And Bohr did not give a justification why angular momentum of an electron is an integral multiple of h by 2 pi. Why he has taken angular momentum of an electron is an integral multiple of h by 2 pi was also a problem. We are going for hydrogen spectrum. What is hydrogen spectrum? You take hydrogen gas, I will explain here. You take a discharge tube, you apply a very high voltage, you take hydrogen gas at low pressure, hydrogen gas at a very low pressure, you get here the gas gets ionized and you are getting a spectra. You pass through a prism, and if you are able to get this in the visible region, you will get 4 lines. 4 lines you get. H alpha, H beta, H gamma, H delta. This is called hydrogen spectrum. Hydrogen spectrum. And the wave number is calculated using a Rydberg constant 1 by n1 squared minus 1 by n2 squared. This is the formula. Rydberg constant has a value given here, and this value is given. I can write in per meter, it will be 1096 7800 per meter. This is the value for R, Rydberg constant. You can get this. Where N1 is the inner orbital, N2 is the outer orbital, by which you can calculate the wavelength. How many series of lines are possible? You should know hydrogen spectrum gives 5 series. Which are the 5 series? Lyman series, Balmer series, Paschen series, Brackett series, and Hund series. And there is a 6th series called Humphrey series also. And see that, interesting. Lyman series comes in which region? Ultraviolet. Balmer comes in visible region. The 4 lines H alpha, H beta, H gamma, H delta comes in the visible region. Paschen, infrared. Brackett, infrared. Hund, infrared. Humphrey also infrared. How do you explain this? So many line spectra what you get, how do you explain that by using Bohr's model? You can do it. If the electron has jumped from first level to the second level, it will come back from the second level to the first level. One radiation, one frequency. It can also excite it to n is equal to 3, then it will come back. It can be getting excited to 4, then it can come back to n is equal to 1. 5, it can come back. 6, it can come back. 7, it can come back. Therefore, you will get Lyman series when an electron from any higher level comes back to n is equal to 1. This will be very high energy that will be observed in UV region. Balmer series is from any higher level, electron is jumping to n is equal to 2. Don't be under the impression that n is equal to 2, it will be there. No. From n is equal to 2, it can come back to n is equal to 1. Then it will form in the Lyman series. But this from higher levels, if it comes to n is equal to 2, it is called Balmer series. Similarly, from any higher level to n is equal to 3, it is called Paschen. From any higher level, n is equal to 4 is called Brackett. From any higher level, n is equal to 5 is called infrared region, that is Hund series. Therefore, you could explain the formation of hydrogen spectrum using Bohr's model. Yes. I will take up one important point here. Number of lines in hydrogen spectrum is given by the formula n into n minus 1 by 2. Remember this formula. N is the level to which it is excited. Let us say 5th level it is excited. If it is excited to 5th level, 5 into 5 minus 1 is 4 by 2. Therefore, it will give you 10 lines. If it is excited to a given level, when it returns back to the ground level, how many lines it can produce is given by the formula n into n minus 1 by 2. Remember. Now, photoelectric effect. What is photoelectric effect? You know, I told you the same figure earlier. This is the cathode, this is the anode. Now what you do is you apply a high voltage. And if you are applying the light here, when light falls on this, electrons are ejected. When light is made to fall on this, no heating is done, light is falling on the metal, electrons are ejected, electrons come here. And we can find this. Electrons are coming here. The electrons are ejected from the metal surface when electromagnetic waves sufficiently high frequency strike the metal surface. Therefore, light falls on this, electrons will come out. In order to eject it from the metal surface, an electron can absorb only one quantum of electromagnetic wave. If the energy of the quantum is sufficient for the electron to overcome the forces of attraction, then the electron might be ejected from the metal surface. Please remember, if this energy of the electromagnetic wave is very high, you are able to knock out an electron from here and electron will come out with kinetic energy. If this is of very low energy, you may not be able to get the electron to the surface. Therefore, first electron should be brought to the surface and then should be knocked out from the surface. That is the amount of energy required by the electromagnetic radiation. Therefore, what we can do here is, instead of reading this, I will say The total energy is h nu. The minimum energy required to bring the electron to the surface is called work function. This is called work function. And then there is kinetic energy. If you supply only that energy required, if nu is greater than nu naught, if the energy frequency is more than the work function frequency, then there will be kinetic energy. If nu is less than nu naught, there is no photoelectric effect. If this energy is less than nu naught, then it will not have any photoelectric. Photoelectric effect is when light falls on that, metal should emit electron. That should be known. Therefore, this is called work function. This is called work function. Psi is written, no? This is called work function. H nu naught. Please remember. Therefore, it is given h nu is equal to h nu naught plus kinetic energy. Don't worry about also thing. Black body radiation. What is the black body radiation? What is the black body? Please remember. Any body, if I take a steel also, steel object. If you heat it, as you heat it, it will emit radiations of different wavelengths. Therefore, when a material, when it is heated, it emits radiation of different wavelengths, then it is almost a black body type. It will absorb all the radiations falling on it. It can absorb all the radiations falling on it. It can emit all the radiations falling on it. Then it is a black body. Now, what we observe here is when you heat steel, the color of steel goes on changing from first yellow, then it will become white also. Yellow then changes to white. Therefore, why the color changes? The reason is simple. First, it was like this. Most of these you can see here, power density. You can see here, it was like this. The intensity of absorption comes down. Earlier it was 724, now 580, now 483. As the temperature increases, the absorption of maximum goes to the shorter wavelength. Therefore, colors also you can see the color of the material goes on changing. What color was emitted? Earlier it was yellow, I say, then it will become blue. The color is changing. The color black body gets changed because intensity of absorption shifts to shorter wavelength. Wavelength goes on decreasing. This is what we call it as black body radiation. Okay. With all that in mind, we will be moving to de Broglie equation. I will make it simple, de Broglie equation. Any particle which is moving should be associated with a wave called a matter wave. Every particle is associated with a wave called matter wave. Therefore, wavelength of this wave is given by h by mp. This is called de Broglie equation. Any matter wave has a wavelength which is given by h by mp. Remember. Heisenberg uncertainty principle says if there is, it is impossible to determine the exact position and exact momentum. This is an error in momentum. This is the error in position. Should be greater or equal to h by 4 pi. If you say the particle is exactly here, if you are locating the position, then its velocity you cannot decide only. Mass you can have, mass fixed, but velocity. Momentum means what? Momentum is nothing but mass into velocity. Therefore, delta P is what? Mass into change in velocity. Change in velocity. Therefore, you cannot fix. Therefore, there will be error in determining the position. Error in determining the momentum should be always greater or equal to h by 4 pi is given by Heisenberg uncertainty principle. Next. Moving from this, we are moving to a very important concept called quantum mechanical model. What quantum mechanical model says is there are 4 quantum numbers. The position of an electron in an atom can be explained by 4 quantum numbers. Which are the 4 quantum numbers? One is principal quantum number. What the principal quantum number? N can indicate the shell to which electron belongs. N can take values 1 to infinity. N is equal to 1 is K shell. N is equal to 2 is L shell. N is equal to 3 is M shell. Like that, shell to which electron belongs is given by this. And number of electrons in a shell is given by 2n square. Please remember. This is called principal quantum number. Azimuthal quantum number indicates the shape of the orbital. That was size of an orbital. See the difference? Orbit and orbital are different. Principal quantum number gives the size of an orbital, and azimuthal quantum number gives the shape of the orbital. Shape of the orbital. What is the value of L you can have? L can have values 0 to n minus 1. Therefore, n is equal to 1 means L can be 0. N is equal to 1 means L can be only 0. Nothing else. L is equal to 0 means S subshell. Only you can have S subshell. N is equal to 2 means L can have two values. L can be 0 or L is equal to 1. One is S, another one is P. S and P subshell. N is equal to 3 means L can have three values, 0, 1 and 2. S, P, D. N is equal to 4 means you can have four values L, 0, 1, 2 and 3. Like that you can have orbital angular momentum, need not worry about it. Magnetic quantum number can have orientation of the orbital. Orbital can have how many orientations possible? It can go from minus L to plus L. I will show you here. Here we are. L is equal to 1. M can have three values, minus 1, 0, plus 1. Therefore, P will have Px, Py, Pz, three orbitals. L is equal to 2. M can have five orbitals, minus 2, minus 1, 0, plus 1, plus 2. Like that you can have. Spin. Spin of an electron can have two variations, plus half and minus half. There are two variations possible. This is S orbital is spherical, P orbital is dumbbell, D orbital is double dumbbell. This is called dxy, dyz, dxz, dx squared minus y squared, and dz squared. These are the orbitals. And this is how it goes. Spherical dumbbell. See, dumbbell is shown like this. This is how they are shown. Okay. Rules for writing electronic configuration of Bohr principle, please. Notice. You can fill the electrons in an atom in the increasing order of energy. 1s, after that you can go to 2s, then 3s to 3p, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, like that it goes. This is called off-Bohr principle. What Pauli's exclusion principle says, an orbital can accommodate maximum 2 electrons. One clockwise, another anti-clockwise. You cannot have both the electrons like this. Is not correct. This is not correct. This is only correct. Hund's rule, what does it say? If you have P, D and F, P has 3 orbitals, D has 5 orbitals, F has 7 orbitals. Before you do the pairing, each one should have 1, 1, 1 electron only. Then only you can have pairing. Then pairing. See, here 1, 1, 1. After that, next one, pairing. Next one, another pairing. And next one, another pairing. Pairing will take place when all the orbitals are singly occupied. That is the meaning of Hund's rule. Exception. This is the last part. Electronic configuration of most of the atoms follow off-Bohr principle. But chromium you check, this should have been the case for chromium. But what happens here is, it is 3d5-4s1. 3d5-4s1 because the subshell is half filled. When the subshell is half filled or completely filled, it gives extra stability. Therefore, one electron from 4s comes to 3d. Same thing here, copper 3d10-4s1 because by shifting one electron from 4s to 3d, the subshell is completely filled. That is the reason. Node. What is a node? Please notice. There are two types of node. I will show you because this is something which people are not very sure. This is the nucleus. This is the first orbit. orbital, I can say. This is my second orbital. Between first orbital and second orbital, there is a space where you cannot locate an electron spherically. Here you cannot. You can find electron here on this part. You can find electron here inside. See, this is not shell model. This is quantum mechanical model. This is one orbital. Orbital is spherical. Here on the second periphery you can find, and here on the first periphery also you can find, but less electron. But in this region you cannot find. One spherical region you cannot find. That is region where you cannot find electron is called node. Therefore, for a 2s, there is one circular node. Circular node is there. That is called radial or spherical node. Angular node is dumbbell. See, if I write a dumbbell like this, here you don't find an electron. No. Therefore, L is equal to 1 represent dumbbell, no? P orbital. P's orbital is like this. Therefore, it has a horizontal node and a vertical node. There are two nodes. L is equal. Therefore, number of nodal nodes, angular nodes is given by L. Number of spherical nodes are given by n minus L minus 1. This is the formula for spherical nodes. This is the formula for angular nodes. Therefore, total nodes is equal to n minus L minus 1 plus L. If you do, that is equal to n minus 1. This is the number of nodes. Okay. We have completed whatever that to be discussed. In brief, I have taken up the portion of atomic structure. Now I will be taking few questions which have appeared in the earlier examination, which you will be able to answer. Let us see. First question. The threshold wavelength for ejection of electron from a metal is 310 nanometer. The energy of the emitted photon is 36 into 10 to the power minus 20 joules. Then the frequency of incident light is. Please keep it in mind. If something is there on emitted photon is there, that means it is the question from photoelectric effect. If it is a photoelectric effect, immediately you should know that h nu is equal to h nu naught plus kinetic energy. This is the formula. Now, the emitted photon is 36. Kinetic energy of the emitted photon is 36 into 10 to the power minus 20. This is kinetic energy plus joules you are taking. Therefore, H should be known 6.625 into 10 to the power minus 34. H is Planck's constant. What is nu naught? Threshold wavelength projection. Threshold frequency is 310. 310 is, how do you write nu naught? This is wavelength. Nu naught is equal to C by lambda naught. C is equal to nu naught by lambda naught. If you remember, then you can do it. What is C? Velocity of light, 3 into 10 to the power 8. Lambda naught is 310 nanometer. 310 into nanometer is 10 to the power minus 9. This should be giving you energy h nu. But what they have asked is nu. Therefore, divide by h, you will get that. But how to work out this? I will tell you the method. You keep this as it is, 6.625 into 10 to the power minus 34 into 3 into 10 to the power 8. This also, you make it as 300. 310, you make it 300. 300 into 10 to the power minus 9 is 3 into 10 to the power minus 7. 3 goes. This 8 and minus 7 goes to the numerator as plus 7 and 8, 15. Therefore, this will become 6.625 into 10 to the power This is 15 and minus 34 is minus 19. This we get. Now, if you are interested, this is the H. If I are interested in nu, what should I do? 6.625 into 10 to the power minus 19 divided by H 6.625 into 10 to the power minus 34. If you do, you will get this answer. How much you get? Sorry, you should have added this. No, we did a mistake. Sorry. 1 minute, 1 minute. We did not do. This is first part. For 36, you should add. This will become equal to 66.25 into 10 to the power minus 20 you do. Because this also has 10 to the power minus 20. 66 plus 36 together becomes 102. 102 into 10 to the power minus 20 you do. Now for this total, because this plus this total, you should divide by 6.625 into 10 to the power minus 34 if you have to do. Now it's simple. 100 by 6 is 16 into this goes up, that means 10 to the power 14. This is the hertz. How do you write it? 1.6 into 10 to the power 15. This is the answer. 1.5 into 10 to the power 15 hertz. This is the answer for this given question. Check. Same formula only I have given. I worked out the problem and answer is the first one. Second, all electrons in simple hydrogen atom are excited to n is equal to 7. Hello. 5 more minutes. Hello. Okay. All electrons in simple hydrogen atom are excited. the first line of gamma series for beryllium is. Therefore, wave number, if you say nu bar of hydrogen divided by nu bar of beryllium. Now you should know that this is the formula you should remember. The nu bar is equal to R by n squared, R that squared by n squared. Remember, first line means n is 1 only. Therefore, this nu h means RH. Nu bar beryllium means R that beryllium square. Therefore, you should have here that H square divided by that beryllium square. Easily you can work out now. If you know 1 is 15,200, you do not know this, which you are supposed to calculate, but you know hydrogen is 1, 1 squared is 1. Beryllium is 4, 4 squared is 16. Just multiply this with this, you will get this. Therefore, just multiply the two, 15,200 into 16, you should get the answer. See, answer is 1. Which is that one, sir? Answer is 2.43 into 10 to the power minus 5 centimeter minus 1. This is that. Seventh question. 4D, 5P, 5F, 6P orbitals are arranged in the decreasing order of energy. Correct option is, this is the question which has come in 2019. Can you remember this? Remember this way. 1s, I will write here, everything will write. 1s, after that 2s, 2p, then come 3s, 3p, then come 4s, 3d, 4p, then come 5s, 4d, 5p, then come 6s, 4d, 5p, sorry, 4f, 5d, 6p, 7s, 5f, 6d, 7p. If you are able to remember that, you can easily now do it. 4d, where does it come? 4d is here. 5p, where does it come? 5p is here. Then come 5f, where is it? 5f is here. 6p, where is it? 6p is here. Therefore, first will be 4d, then 5p, correct? 4d will have the lowest energy, then 5p, then 6p, and 5f. Therefore, answer must be 2. This is how you can answer this. Last question we take. 8. Velocity of an electron in the first Bohr's orbit is this. Its velocity in the second orbit would be, for hydrogen it would be very simple. Bohr's orbit, first orbit is 2.19 into 10 to the power 6. If you write, then velocity of this orbit, any orbit, second orbit, third orbit would be like this. Second orbit would be 2.19 into 10 to the power 6 divided by second orbit is 2. Automatically it will be half of that. 1.14 into 10 to the power 6, it should be meters per second. Answer must be here. Answer is 1. Therefore, remember, Z by N, Z is 1 only. Don't worry. Therefore, I said, you remember this formula. You remember the formula for radius. You remember the formula for energy. You remember the formula for velocity. You should be able to answer most of the questions. Yes. Dear students, we have gone through this, whatever time that was available for us. We have gone through the atomic structure chapter. Go through it again in detail and try to find out what are the things to be learned in this. Some formulae, some understanding is required by which you should be able to do justice to this topic. If you have any question, you can ask me.
Hello, sir.
Yes?
That was
Nobody
very
has any
interesting.
question?
Right now, as of now, there are no questions, sir.
Okay.
But we had around 10 to 12 students who are playback watching in the YouTube since they couldn't join for Cisco WebEx.
Okay.
And some 5 to 7 students who joined for Cisco.
Okay. If they do not have any question, no problem. We can wind up the session for the day.
Yeah. So on behalf of PSTA,
Yes.
Karnataka Science and Technology Academy, Chairman S. Ayappan, CEO A.M. Ramesh, and all the official staff who are here, who are supporting this program at the outstretch, I sincerely thank them. And on behalf of them, I thank you for spending your 1 hour time with the students, solving the neat questions which help them in the upcoming exam. So thank you very much. I request students to put some questions through mail so that we can send it to the sir, and later sir will get back to you the question answers for the same through the mail. I'll share the email with you, students, so that you can share the you can ask the questions to the sir. So thank you very much, sir. I thank you very much. It's the second talk by you. We hope to see you many more talks from you in the future days, sir. Thank you very much.
Thank you. Thank you very much.
ಧನ್ಯವಾದಗಳು.
Yes, ಧನ್ಯವಾದಗಳು.